Hi everyone, welcome to Soft Tutorials. Today I'm going to be showing you the resolution of several vectors. Now when we're talking about vectors, it could be acceleration, it could be velocity, it could be displacement, but in this case we are looking at force vectors, how we can resolve several vectors and using a special technique. Now this special technique is different from the conventional method that a lot of people are used to. Actually, I've not seen it in any textbook, I've not seen it in any videos before, but because of my experience in teaching, and I was able to come up with it, and it has really worked. Now sorry, now when you have, say you have several forces as we have here, you have f1, f2, f3, f1 and the likes. Now how can you resolve this? Let's say each of these forces are inclined to the horizontal. Let's say this is theta 1, right? Let's say this is theta 2, let's say this is theta 3, and let's say this is theta 4. Of course others would also be inclined to the horizontal. Now let's focus. Now how do you resolve all these forces? Now I'm going to focus on f1, I'm going to focus on f2, rather f4, f6 and f8. Now if you look at this, these are vectors that goes like this. You have another one like this, you have another one like this, and there's another one that goes like this. Now this is what you notice: any vector that goes like this, like this, like this, or like this, they have component on both x and y. I repeat, any vector that goes in this direction, they have component on x. What does that statement mean? It implies that if I want to relate it to this is actually f2 in this case, this one is f4, this one is f6, and this is f8. Now how do you resolve vectors in this form? One thing you need to note is that the vector, say the force along the x component is plus or minus f cos theta. I will explain that later. Then the vector along y is the same thing as plus or minus f sine theta. Now what does this statement imply? It actually implies that any vector along the x, if you are resolving along the x component, could either carry positive or negative. How do you know if it carries positive or negative? Now this is how you know. Remember this coordinate, this is positive y, this is negative y, this is positive x, y this is negative x. Now what I'm saying now is, for example, if if we want to resolve f2 is along positive y and negative x. This f2 here is along positive y and negative x, which implies that if I'm going to resolve it, the x component is positive. So instead of f of x to be plus or minus, it will be plus f cos theta, where theta is the angle of inclination to the horizontal. So this is theta, that's the angle of inclination of f2. That one must be registered, the angle must be inclined to the horizontal. Now if I'm going to resolve f4, this is f4 here, f4 is gonna be in this area. Now f4 has component on positive y and negative x. So if I want to pick the y component, it will be f in the positive y direction will be f sine theta, because it's on positive, so you won't pick the negative. Now the x will now be f minus f cos theta, rather, right? Instead of you picking plus, you pick the negative, because it's on negative x component. Now if I want to pick another one like f8, now f8 is here, it has component on positive x and negative y. Now if you look at it now, this is if you want to pick the x will now be f along x is f cos theta, and f along y will be negative f sine theta. Now the reason why it is so is because it's on positive x and negative y. Of course the same thing applies to this. Of course, you know that this one will represent f6 here, so f6 is on negative x, so the x component is negative, and the y component is also negative, so it will now be f along s is what? Minus f cos theta. F along y is what? Minus f what? Sine what? Theta. And don't forget, anytime you are resolving this particular type of problem, the angle of inclination must be to the what? To the horizontal. Now in the next video, I'm going to be showing you how we can represent it on table with respect to their what? Angle of inclination.